last lesson, we learned some classic cases of point optical illusions. In this lesson, we will study the line illusion in the composition of optical illusion space. The line optical illusion has three main types. The first is the unequal length illusion of equal length lines. The second is the illusion against the background of oblique lines. The third is the illusion of odd lines. Let's start by learning about the unequal length illusion of equal length lines. Two line segments of equal length can appear unequal under the influence of their surroundings. This is due to the strong influence of the surroundings exerted on the lines. The most representative example of this illusion is the Ponto illusion and the Mueller-Lyer illusion. Let's take a look at the Ponto illusion first. It was discovered by the Italian psychologist Mario Ponto. He believed that the human brain estimates the size of an object based on its surrounding environment. He demonstrated this illusion by drawing two completely identical lines crossing a pair of converging lines resembling railroad tracks. The top line appears longer due to the principle of linear perspective. The two converging lines are actually two parallel lines extending infinitely. In this situation, we perceive the top line as being further away, hence appearing longer. Because when two objects at different distances present images of the same size on the retina, the object farther away will appear larger than the one closer. Next, let's look at the Mueller-Lyer illusion. The Mueller-Lyer illusion is created based on two line segments of equal length. If one has outward-facing arrowheads at both ends, and the other has inward-facing arrowheads at both ends, which line appears longer? You might think this is an old question, or reason tells you to measure them with a ruler. But you have to admit, the line at the top appears longer, when in fact they are both the same length. This is the Mueller-Lyer illusion, also known as the arrowhead illusion. There is a theory for this illusion called the neural inhibition theory. When two contours are close to each other, the adjacent neural clusters on the retina will inhibit each other, resulting in contour displacement and thus creating the optical illusion. Additionally, the arrowheads have a perspective effect. The second type of the line optical illusion is the illusion against the background of oblique lines. In this kind of background, straight lines appear curved, and parallel lines appear non-parallel and seem to be bowed outwards or inwards. The most famous examples of this illusion are the herring illusion, wand illusion, and donut illusion. Let's take a look at the herring illusion. It was discovered by the German psychologist Ewald Hering in the 19th century. He found a pair of parallel lines appear to be bowed outwards when superimposed on a series of straight lines radiating from a central point between the parallel lines. This illusion is a wrong perception caused by empiricism or improper references. The one illusion proposed by the German psychologist and philosopher Wilhelm Wundt in 1896 is that two parallel lines distorted by a set of rhombi appear non-parallel, but seem to be bowed inwards, which is in direct contrast to the herring illusion. So let's compare them. The herring illusion shows two parallel lines appearing to be bowed outwards in the middle, while the one illusion shows two parallel lines appearing to be bowed inwards in the middle. The donut illusion is that parallel lines appear non-parallel due to some additional line segments. For such geometric illusions, neurophysiological theory suggests that when two contours are close to each other, their projections on the retina are close, causing mutual inhibition between the nerve cells on the retina. leading to the illusion of geometric shapes and the direction of motion. In the figure, we can see when the parallel oblique lines cross the parallel straight lines, the parallel lines appear curved. In fact, they are all illusions against the background of lines, and with a natural sense of distortion. Next, let's look at the illusion of odd lines. Within the line optical illusions, when odd lines, also known as curved lines, serve as a background, the straight lines on the background will not appear straight, and the squares on it will not appear square. The most representative one is the Fraser spiral illusion. It was introduced by the British psychologist James Fraser in 1908. This figure generates optical illusions in both angle and direction, which is called the king of optical illusions. It is mainly caused by the directional black lines in the background that are internally tangent to the circle and slightly divergent outward, stimulating our visual cells sensitive to orientation and thus inducing a spiral illusion. The figure you see seems to be spiral, but in fact it is composed of concentric circles. If you don't believe it, just draw along the line with a pen, and you will find they are really concentric circles. These are classic cases of optical illusions of lines. Now let's review the 3 classifications of optical illusions of lines. The first is the unequal length illusion of equal length lines. The second is the illusion against the background of oblique lines. The third is the illusion of odd lines. For the exercise of this lesson, you are required to finish a composition of a line optical illusion space based on the classic cases. In the next lesson, we will discuss the classification of surface optical illusions and the methods of creating the optical illusion space. Alright, that's all for this lesson. See you next time.